Sure, it might be hard to make stress melt away, but in this tutorial, I'm gonna show you how to harness the power of Cinema 4D's particle system to create liquidy-like melting simulations, perfect for dissolving everything except that existential dread lurking in your subconscious.
Come on, Eeyore. Let's get to the bottom of this.
I'm already at the bottom.
We're going to be covering a lot, so if you want to follow along and even pick apart how I built that Redshift gel shader, be sure to download the project files. The link is in the description. All right, so to get started, we need our object that we are going to melt, and that could be any object, and in this case, I'm going to melt some type. Why not? And so I'm going to grab a MoText object. Let's make the depth a little bit deeper, and let's change the alignment to middle, and let's just choose a single letter. Let's start with A. It's the start of the alphabet. At least that's what I was told in school. School wasn't very good, so I don't know if that's true or not. And we're just going to have that like that. And we're going to have a more thick object that we can work with. So I'm going to choose a different font like Ruka. I believe this is in Creative Cloud. So if you have Creative Cloud, you have Rika, I'm not sure. But we don't have to worry about it looking like a piece of gelatin or a blob just yet, because we're going to ultimately throw this into a volume builder, volume mesher. So we don't need to worry about needing rounded edges or anything with this piece of MoText, okay? So how we're going to do this effect is using Cinema 4D's particles. So what we're going to do is we're basically going to have a bunch of particles that fill up this volume and then melt those particles away in Volume Builder, Volume Mesh it, okay? So the first step is we need a bunch of particles to fill up the volume of this MoText object. So what we're going to do is go to Simulate. This is where all the particle stuff lives. And we're going to go to Emitter, and we're going to choose Mesh Emitter. And this is really cool because it allows you to emit particles based off of a mesh. And because I had that MoText object selected, it's going to automatically throw that text object in the geometry slot of this mesh emitter. Now, one thing to notice is that unlike the old emitter system, we have two objects that are created when we add an emitter to our scene. So we have the emitter, which has all the particle data, and then we have a particle group, which is actually where the particles will live. So that means if you want to adjust the scale, or you want to render the particle, the rendered particles are going to appear from this group. It's also where you can apply different forces and modifiers to a single group. So you can work with multiple groups, apply different forces to different groups, which I'll show you a little bit later. But just to know what's going on behind the scenes, we have the data here and the actual particle information in the particle group. Okay, so what we're going to do now is if we hit play, you're going to see a bunch of particles are just emitting from, if you look in the default mode here, it's just emitting from the surface of this object. You can emit from points, or in our case, we want to emit from the volume. And we just don't want particles to fly all over the place. So I'm going to go and bring down the speed to 0. And so you're not just seeing anything really, you're having some particles emit on the surface there. Let's actually go to our text object, right click, and I'm just going to type in display, and I'm just going to use this just to get our lines so we can see a little bit of a wireframe of our text, so we can see all those particles generating inside of our object there. Now, we don't want particles just to emit over time. We want a single shot of a lot of particles that are generated at frame 1 that we can then manipulate and start to melt. So what we're going to do is this emission mode we're going to do to a single shot, and the count is going to be, let's try 50,000 at first. And this can change depending on the size of your object, the scale of your object. So kind of play around with the count. Just make sure that all the particles kind of fill up the object well. You can see that we got the staggered kind of 8-bit look, and that's because of the voxel size here is too big. If we move this down to 1, you can see that it's going to sample that volume of the object better and fill it out more accurately. So now we got a bunch of particles emitted inside the volume of this object. So now what we can do is we need to basically apply that melt effect.
I'm melting!
And if you need melting, you need gravity. So we need gravity, and we need something for these particles to collide into. So let's first create a floor, just a plain object, and make this a little bit bigger. Let's move our text object up a little bit, and let's maybe make it off kilter a little bit too, so we have something like that. And then we'll rewind, go to frame 0, and then we're going to apply some gravity. So we'll go to forces, gravity, and hit play. You'll see absolutely nothing's going to happen because just like with normal simulations, you need to basically identify certain objects to be collided into. So the great thing about the particle system in Cinema 4D is it plays very nicely with all the other simulation aspects in Cinema. So rigid bodies, soft bodies, all that kind of stuff, even pyro, it's all unified, all plays together nicely. So I need to do two things to make these particles collide into this plane object. Number one is make this plane object a collider by adding a collider tag to it. And number two, I need to tell the particles that, hey, you need to recognize dynamic objects in your scene. So I'm going to go to simulate modifiers and go to collide. And so with that collide, I can go and hit play. And you can see that we got some collisions and then everything's just kind of falling through. And this kind of illustrates a very important aspect of modifiers in the order of operations. It's much like the order of operations with deformers and different types of aspects of Cinema 4D. So whatever modifier is happening first is going to calculate first. So right now it's a little bit weird as far as the order of operations. We have collision and then we have gravity happening after the collision. So that doesn't make much sense, right? We should have gravity and then collide, right? So we're just going to move this down. And actually I'm going to go and just make this nice and organized because we're going to have multiple particle groups here ultimately. So I'm just going to say, okay, all these modifiers are just going to affect this particle group. And so now we have gravity happening and then the collide, and we don't have anything kind of going through our plane object there, which is good, right? So now we can go to this new collide modifier and we can dive into some of these settings. So the main thing is I don't want any bounce. Collision iterations we can just leave. That's basically just adding extra calculations so there's no particles going through objects or geometry. And then the dynamic friction here we can actually up to something high like 5,000. And this will just allow this to have like nice dynamic friction so it's not going to go anywhere. And then to make this so when it impacts an object, collides into an object, it can kind of spread at different angles. We can just up that angle variation. You can see that we have a little bit of like spreading happening than before we had that angle variation there. So that just adds a little bit more organicness there. So far this is looking good, but this is all colliding into a plane and it's got no volume, no viscosity whatsoever. And the key to this whole melty trick is something called a flock modifier. So let's go to simulate. We're going to go to modifiers and we're going to go to flock. Now, flock doesn't seem like it would do anything, have anything to do with viscosity or anything like that. But what the flock allows you to do is have particles kind of be stuck to one another or push away from one another. If you do those opposite forces, we can have kind of little blobs of particles or flocks of particles that if we manipulate it in a certain way, looks kind of like liquid, okay? So I got this new flock modifier here. Again, I'm placing this in the hierarchy of the particle group and I'm making sure it's happening above that collide there. So it's calculating first. And what I'm going to do is I'm just going to up the strength here. And you can see that when I up the strength, you can see a little bit of stacking going on because the thing is that collide doesn't allow other particles to collide into other particles. It just allows particles to collide into dynamic objects. Okay, so that's kind of the thing there. So what this flock allows us to do is basically when we adjust the cohesion strength, let's up that to like 50. You can see that what this is doing is it's allowing our particles to cohege, if that's a word, stick together into these little droplets. And then, so that's one force. And then we have the opposing force of, instead of cohesion, separation strength. And so if we up the separation strength, you can see that things are kind of stacking on one another. And right now things are just kind of exploding all over the place. And one thing to realize is before you get too far down the rabbit hole of changing settings and stuff like that, by default, if you go to your particle settings by hitting Command or Control D, these are your scene-wide simulation settings. If we dive into the particles tab, just like with simulation, where if you want more accurate simulations, you up the substeps. Same thing with particles. It's got its own specific substeps here. And I'm just going to up this to 10. And you can immediately see we have a much different setup now, where this looks a lot more, dare I say, liquidy and viscousness. I'm just making up words all over the place in this tutorial, but that's fine. And so you can see like already we got something kind of melty blobby looking, okay? And so what we are going to do, and again, this is the key to everything going on here, is this flock. And what I'm going to do is just turn off gravity, because you can see that what's happening is our opposing forces, the overriding force is the suction. And so when we're melting something and we're faking this kind of melting effect, it's not a true fluid simulation. We want to maintain the volume, okay? So that means we need to kind of dial things in and have a little bit of like push and pull. You can see this little kind of blobby, liquidy stuff going on, which is pretty cool in its own right. But what we're going to do at this point, instead of having things kind of float out all over the place, we're going to add a little bit of friction. So dynamic force is friction, and we'll just apply this here. Let's up that strength to like 100. And so now we'll have a little bit of friction that allows these particles to kind of stick together a little bit better. And so you can see the flock effect is creating a bigger volume than what we started with. So that's again where we have this push and pull kind of effect. So let's bring down the separation radius, because really we want it not to shrink too much, but we also don't want it to expand out much bigger than the original volume that we had. So I'm just going to dial in these settings here. And maybe something like that's looking pretty good. And I'll turn back on the gravity. And so now this melts pretty nicely and it maintains the same volume that we had before. Now, one thing we can do is we can have this look a little bit more liquidy. And so when groups of these particles move together, we can actually have the strength of which two particles or multiple particles move in the same direction by upping this velocity alignment strength. So if I up that to say 20, this is going to allow different particle groups to like go in their own direction, and kind of if we had like strands of little goopy liquid, it will help maintain that velocity of those groups of particles. So we'll see this a little bit later on, but I'll up that to 20. And that's basically all I'm going to mess with in this setup here in the flock. Okay. So right now we just have a bunch of particles just kind of falling. It doesn't look all that interesting whatsoever. What would be cool though, is if we could kind of have more art direction on this whole liquidy melt effect by having different parts of the particle setup, the volume, melt at different times. And so we can actually use fields to control this type of thing. And how we can utilize fields is by creating two different particle groups. Okay, so I've mentioned how you can have different modifiers affect different particle groups. So we can actually have a starting particle group that's just static, and we can have a second particle group that has the gravity, the friction, the flock, and all that stuff. And we can have that kind of control which particle's part of which particle group and which modifiers, and control that using a field. Okay. So I don't know if that made much sense. Didn't make much sense when I said it. Let me just do it and you can see what's going on. Now, before we move on, if you're ready to dive deeper into Cinema 4D simulations and more advanced 3D concepts, be sure to check out my intermediate Cinema 4D course, Cinema 4D Ascent, at schoolofmotion.com. It'll help you create animations that will melt your clients' hearts.
It's so beautiful.
The link is in the description. All right, let's get back to it. So I'm going to create a whole new particle group. Let's go to simulate and we'll go to groups and we'll add a particle group. Now we have two particle groups here. Our original one, which I'm going to name static. And then the second particle group, which I will name melt. So we can clearly know what each one is doing. Okay. And so if I hit play, you can see if I select this particle group, you can see I'm selecting all those particles. When I select this group, there's no particles in this group, this melt group, okay? So what I'm gonna do is I want that static group to just generate the particles and just wait for us to apply the fields to have that trigger all these other effects. So what I'm gonna do is I'm gonna move all these particle effects and just apply them to this melt. And actually I want both these particle groups to use this collide modifier. So I'm gonna move that outside of that melt group, so it affects both the particle groups. So it's just like if you had one object in the same level of hierarchy as other objects, it will affect those other objects in the same level of hierarchy. Same thing with modifiers and stuff like that. So now we have this first static particle group, nothing's happening. And then we have this second group that has all the melty effects. So how do we get particles from one to switch to this other group using fields? Okay, well, what we're gonna do is we're gonna have this static group and we're gonna go to simulate, we are gonna go to conditions, and we're gonna choose a field condition. So basically this is gonna allow us to use fields to control different aspects of the particle data. And so I just want this field condition to control this static particle group. So I'll make sure it's a child of that group. And so you can see with that field condition selected, you can see we have our field list that is just like MoGraph effectors, deformers, all that stuff. We're going to load up all of our favorite fields. And so we can go in here and let's grab like a linear field, have it face downward, and we'll just kind of adjust this so it's just touching the bottom there. So something like that. And basically we want it so like if we pass this linear field through, it's going to switch the static particles to the melty particles with all the modifiers that create that kind of fake melty effect. But we need to do one thing to be able to switch particles from one group to another. And so what we're going to do, we're going to go to simulate and go to modifiers, and we're going to grab the switch group modifier. We're going to make sure we make that a child of the field condition, because basically this is going to basically be driven by the fields here. So the switch group is going to say, okay, so when a field passes through a particle, we're going to switch that particle in this group to another group. What group is that going to be? It's going to be that melt group, okay? And so with that, I can hit play, and if I move this through, check that out, it's moving. Let's actually give ourselves a little bit more time here, 150, and I'm going to select this group here, and so you can see the objects that are below, the particles that are below this linear field have switched groups, join the melt group with all the fun particle modifiers that make it look like it's melting. And then everything that's not affected by that field, which is above this linear field, is still a part of that static group. So when we pass through that linear field from one to the other, you can see we're switching groups and just applying those particle forces to those other particles, okay? So that's the name of the game. That's how we're controlling this. But again, this doesn't look super interesting. It's too linear, too boring. So what we can do is start to utilize all the different cool fields that we all know and love. One of my favorite ones is the freeze layer. And what the freeze layer allows us to do is take any kind of field effect and grow it across the surface or across a bunch of particles. So I'm going to add a freeze layer. We're going to change the blending to max, which is basically like a additive mode. And then we can change the mode to grow. And so if I go and I click on this particle, let's go to frame 0, hit play. You can see that our particles, our field is just touching the bottom particles. But then with this freeze growth effect, it's growing that effect over time based on this radius and effect strength, okay? So you can see we're switching particles from one group to another, and we're getting this kind of cool little liquidy melt effect. Look at that. So we have this flock, we have the friction, we have this switch group. What we can do now is make this look a little bit more organic. So this, again, is too linear, so we can kind of break this up using different types of field. So we can use a shader field to kind of adjust how much strength that freeze layer is kind of being applied across all the particles. So we're just going to go and load up some noise here and go into the noise shader. It's up to like 150. And let's change the noise to, say, a turbulence. And let's see what that looks like. So if we go to our field condition, let's just change this to subtract. And we'll just bring down the opacity just a little bit. And so what we should see if I click on this group melt is instead of just a linear transition, we're seeing a little bit of breakup there, a little bit more organic kind of look there. And so you see that it's moving kind of slowly as it's using that noise almost as like a mask there. You can see it's growing across. And so to make this work a little bit better, I'm actually going to have this noise. Let's have this animate. So the noise is going to constantly be undulating. And so now you can start to see what's going on there. And so we got a little bit more. It's not linear anymore. We got this really cool thing happening, and that's looking pretty nice, if I do say so myself. And what we can do is we can layer up like different fields. So instead of just a linear field, let's actually just move this down. We can also say like, oh, I want melting to start right here too. So I can go in, let's grab a spherical field. We'll set that to max under here as well. And we'll shrink this down. Whoops. Select just the spherical field there, and we'll just touch the volume there. And so now if I select that particle melt, you can see now we're melting from the bottom and this corner here where that spherical field is, and we have that freeze growth happening from both sides of the letter there. But right now we have this melting, and when something melts, unless it's fixed in space, usually the object would kind of fall as it's melting. There'd be a little bit of gravity there. But right now, we don't have any gravity happening in this static group. So what we can do is we can command click and drag, duplicate the gravity over here, but we don't want this to have like the full power of gravity, because then we're just back to square one. Okay, so what we're gonna do is we're gonna take this gravity and maybe bring it down to like a fraction of the normal acceleration. So as this moves down, you can see we got the gravity on the first group, and everything kind of looks in concert. So it's kind of just matching the speeds. Again, we're faking this effect. So we're faking the volume maintained. We're faking that the top is melting and going down with the bottom at the same rate of speed. And so that's looking pretty close there. Now, the other thing is that when something melts, the structural integrity, that's a very scientific word for me.
And I am street smart and book smart.
The structural integrity will start to kind of, switch at the top of the object. It's not going to just stay super static. So what we can do is kind of break up the volume of the static particles by just throwing in another force, like let's do a turbulence force. Again, just apply that to that static group. And you can see what this is going to do if we just really crank this up. So this is way too high. So let's just bring the strength down to like 0.1. Bring down the frequency too. And so we just want a little bit of movement. So as this goes down, we're going to have a little bit of turbulence, start to push the particles a little bit, break it up. So it looks a little bit more organic as the structural integrity degrades over time. You can start to see that breakup happening with that going on there. Now, I'd say this growth is happening a little bit too much. So that's where we can go into the freeze layer and maybe like bring down the effect strength, which should slow down how quickly the field forces and that freeze layer growth is going to pass through this object. Okay, so again, it's all about matching the speed of everything. So maybe now this gravity effect is too much. Maybe we need to slow that down. So all about matching things here. And so at this point, we can throw this into our volume builder, volume mesher. So let's see how this actually looks as a melty little blob. So we're going to go to our volume builder, volume mesher, and we're just going to bring this below the particles because we want the particles to generate and then we want to mesh them, right? So we're going to go to the particle builder. And if I go and hit play, the big important thing is that you place both particle groups in here, because if I just place the melt one in, we're only meshing the melt particles. So I need to bring in both the static and the melt. I'm going to set that to union. Right now the voxel size is pretty big. Let's bring that down to 1.5. And then you can see these are basically just big spheres. So those sizes of those spheres are controlled by the radius in each of these different groups. So I'm just going to bring this down to like 4 and 4. And now this looks like just gross cottage cheese. So we're just going to smooth that out. And let's bring up the iterations there. So again, this is where we have this nice blobby type of effect. Another thing we can do is let's use some close and open here. And this will just kind of, if I do before and after, this is just kind of help connect some of the blobs together a little bit more, maybe bring down the offset there a little bit. So it's just growing out our blobs a little bit. And let's go, you bring down the smoothness a little bit. So now we can hit play and we can see our little blobby melt kind of thing going on here. So this is looking pretty good as we're going through here. Now, the thing that the volume builder, volume mesher does is you might lose a little bit of the volume depending on how big your voxel size is and all that kind of stuff. So what you can do at this point is go and kind of tweak the flock settings and stuff like that. So maybe we need a little bit more of that separation radius, which is just how much of a barrier there is between each of these particles. So if you up that separation radius, you'll get a little bit of a thicker kind of melt going on basically. And you can see as we're going here, we're getting some pretty nice looking effects here. And this is where, upping the velocity alignment strength and adjusting some of these options really helps here. So this is looking really nice. And again, because we have that little turbulence, we're getting a little bit of that deformation at the top of the object too. And so again, we're just faking it right now, but that only took us a little bit of time and that's looking, pretty nice. So I want to show ultimately what I came up with here, and I want to go over one last thing, and that is the particle groups. If you want to render something, so I just applied, let me just play this through here, but I just applied a kind of like a gel shader that I created, and I'm going to provide the download link to this project file so you can see exactly what I did with the shader there. But the one important thing let me just turn these particle groups back on, is I'm going to go and I'm just going to let this play, make this look a little bit good. Got the melty goodness happening here. Hit escape, and I think that's looking pretty good. Now I'm going to go and we're going to go to Redshift Render View. And one important last thing, that's what that shader looks like. Looks pretty good, I would say. It looks kind of gummy. I'm going to hit play, and the one important thing is that, again, when I said when you're generating particles, you have your emitter and your particle group. Well, that particle group controls how that particle is rendered, if you want it to render at all. And so we have these particles being rendered. Those are the green little dots. And so if I select these particle groups, I want to just hide them. I just want them to generate particles. I don't want them to actually render. So that's an easy fix. All I need to do is hit that bottom stoplight to change that to red. So this group will not render. And then you can still see the particles generated from this particle group. And I'll just go and hide that from render view. And so now you'll see we have just the mesh from the volume builder, volume mesher that's being generated, none of the particles inside of there. So now we can go and kind of play this through, and we got this nice little melty blob effect. Now, the one thing you want to do is you'll probably want to go and before you render this, you'll want to cache your particles. So to do that, first I recommend that you turn off your volume builder, volume mesher, because I found issues with if you have the volume builder, volume mesher on and you're trying to cache the particles. So to cache the particles, you're going to select all the groups that you have, and then you're just going to go to cache scene, and this will do its thing and it will cache all these particles. Now, little word of warning, this is a massive file that it generates too. Make sure you have some hard drive space, but we're just going to let this cache. All right, so our cache just finished, and now we can just play through this, and you can see, like, does the timing look good, all that kind of stuff, so you can adjust all your things there. And then before you render, just turn back on your volume builder, volume mesher, and then just go and render. Make sure you render from frame 0 to get the full thing. So I also promised that I would show you how to use other objects other than Motec. So what I'm going to do is I made a little gummy bear here. You can see little gummy bear right there. And all we're going to do is I'm just going to make the same size as the Motex that we're using there. And then what I'm going to do is just replace in the mesh emitter the object that I want to use as that mesh emitter. And so now if I go and turn off the volume builder, volume mesher, play, you'll see instead of generating a bunch of particles inside of the text, it's going to go and generate it inside this gummy bear volume. And so I turn on the volume builder, volume mesher, and we'll have this little teddy bear start to melt, this poor teddy bear. Now, the one thing to kind of be aware of is that because you're making a very gelatinous type of goo object with your volume builder, volume mesher, you want to make sure that your object isn't too highly detailed. So if you have facial features, like I made pretty fine facial features on here, you want to make them a little bit more pronounced, add more contrast to your geometry, because you can see how it gets a little bit lost. Now you can do things like, you know, changing the voxel size and stuff like that, but I feel like the effect starts to fall apart. So a little bit of some guidelines to follow, but it's pretty cool that we can get some fake liquidy type of effects inside of Cinema 4D using the particle system. And there you have it, a super fun way to create melting effects with Cinema 4D's particle system. I hope you enjoyed following along and learned something new about working with Cinema 4D particles and fields. If you create something awesome using these techniques, be sure to drop a comment below. We'd love to see what you create based on this tutorial, so be sure to tag us on all the social medias because we do have some extra fire emojis we can throw in your replies. And we all know I'm a very vain and needy person, so don't forget to like and subscribe to fuel my ego enough that I'll make more Cinema 4D tutorials. All right, that's it from me. Thanks as always for watching, and I'll see you in the next one.